Hello, good afternoon, everybody. Can you hear me okay? Excellent. I am Justin Ritter, Director of Project Operations at Lucas, responsible for all our project delivery and solution design. And joining me is not Andrew Southgate, but Mike Bishop, our Director of New Product Development. I'm here to talk about next generation analytics for warehouse operations, which I'll explain a little bit, but I'm going to do a segment on sort of the first layers of the capability model, and Mike's going to kick it off talking about artificial intelligence and machine learning use cases in analytics. So with that, what we want to cover is the fact that analytics is more than reporting. I'll spend some time on that topic in the next slide, talking a little bit about descriptive and diagnostic analytics. The fact that with a solution like Lucas Systems provides, we can use data from multiple systems. We have insights from historical and real-time data, as well as we're launching a product here at the show called Enterprise Analytics that enables you to look at multi-site trends and comparisons. Mike will cover the next-gen predictive analytics, leveraging IoT data as well as machine learning to get insights from your data. So what's this all mean? So typically when we talk about analytics or business intelligence, we talk about a capability model, and there's really sort of four phases of it. The first phase on the left has to do with descriptive and diagnostic capabilities in analytics. And then the second phase is predictive and prescriptive. So I like to think in terms of warehouse operations. How many people run a warehouse in the audience? Can you raise your hands just so okay, excellent. So most of you are probably familiar with descriptive analytics. So this is really just taking a look at the data you have and trying to understand, what happened. So a lot of the operators that we talk to, they're starting from ground zero, meaning they have some pick data that they've gotten from their RF or paper-based system, and at the end of a week, they'll go and run a report and some analytics to understand what happened. And they're looking at high-level information, and a lot of it tends to be very tedious manipulation and massaging of data. So more of the advanced business or power users will build access databases that are pulling together reports. Some users are doing things in Excel where they're running pivot tables, but this is the time that supervisors are spending crunching and looking at this data rather than managing the workforce and all the work on the floor. Diagnostic analytics is trying to tie in other pieces of data in regards to what drove someone to have that issue. So when I see productivity dipping down, did they have an equipment issue? Were they talking to their supervisor? Were they talking to their friends? Why did we actually get that business result? And then when we talk about predictive and prescriptive, this is sort of taking all that manual work and looking at the data historically. It's looking at the data and trying to predict and actually correct what's happened. That's what Mike will talk about. So as I was talking about, DC analytics is hard. We find that a lot of our clients, they're using ERP or WMS systems, which collects all the information, and it's great from a system of record point of view. But actually to do their jobs and get the data they're looking for, they have to contact IT to do a report. They have to work with the vendor. Oftentimes it's disjointed data sets, so it's hard to join those things together. It's very hard to work with. One of the things that's a trend and something that we provide in our work execution solution is just the volume of data. So traditionally, WMS, you may have an RF-based pick process where you get one timestamp on the pick, and that's essentially the person scanning the location, entering in the quantity, and saying, I picked it. These days, what we provide is a complete visibility into what that picker was doing. So when did they get to the beginning of the aisle? When did they get in front of the pick slot? When did they verify the slot? When did they grab the product? When did they put it into the container they're picking to? And then so on and so forth. That granularity of data enables us to do some cool things from a machine learning perspective that you couldn't do with traditional data sources. Also, one of the things to think about too is it's one thing to have a report that looks at how many short orders I had in a day, but that's really for a supervisor. DC managers, regional directors, and other supply chain executives, that's too low of a level. They want to know high level, how are my DCs performing, and what are the things I need to do to fix them? So with analytics, one of the things that's been happening is the fact that data storage has gone very cheap. Actually, the ability to put this up in the cloud now, it's easier than ever, and it doesn't cost a thing. If you went back a decade ago, it would be a different conversation. More processing power as well. Hardware is very cheap. We can install our solution on a server that costs less than $5,000. It's the least of our concerns. Web reporting and visualization tools. So what we'll talk about in the next slide is our enterprise analytics platform, but there are many solutions out in the marketplace. What we found is it's oftentimes a big burden and a boulder to push up the hill in regards to trying to install a BI platform, getting the IT people together, building out your data warehousing strategy. We have a way to automate that with our new solution. And then one of the things with having more granular data is being able to apply AI and machine learning algorithms, which Mike will talk about. So here's an idea for what we can provide with our enterprise analytics platform. So as not a DC manager, but someone responsible for the entire network, and let's say I had 5 DCs, I can see at a high level how are my DCs performing. So if you have a standard way you measure productivity, in this case we're showing lines per hour, you can see here that 3 of my DCs shown in the green at the top left are performant, while Chicago and Austin, who are in the yellow, are not performant. That may start to lead me to ask other questions, so I can start digging in and looking at trends. Well, is this a new phenomenon over the 2-week period, or is there something else going on? And so you can actually see day by day, and we can roll this over into weeks and months and years eventually, looking back at the data and understanding some of those things. So if I drill into lines per site, then I can get into, well, what's driving that? And so no warehouse is so simple that I can use a single metric, but in this case, we have a customer who's picking on a cart. They're picking eaches into a tote. We call that repack. And then we have another customer who's picking cases directly to a pallet for their trucks. We can actually show the breakout of that information to drill in and see, do I have an issue in my each pick area, or do I have an issue in my case pick area? One of the other things to look at are some of the other issues that may feed productivity. So one of the graphs on here, the bottom one, says units shorted or scratched. So this is the idea of my pickers are actually working at a fast rate. They're going to the slot. They're trying to pick the product. But when they get there, the product isn't there. And that's because replenishment isn't keeping up. So actually seeing that there were spikes in Austin or in Los Angeles over the last couple days with units shorted or scratched gives me some intelligence to go and drill in to understand, did we not have our receipts on time? Did we have issues with replenishment? Perhaps we had issues with the material handling equipment. It helps you ask some of those questions. If I drill into the pick lines by site, I can actually see a detailed summary as well on, maybe I have slower pick rates in one of my more high volume sites that I want to focus on versus a site that has low volume over the last couple of weeks or even by hour. Last thing we can show is we're collecting all this information around product velocity, and so we are able to provide visibility onto what are the highest moving products. So perhaps I need to look at these from a slotting perspective, as well as what are my products that have been shorted the most. And maybe that's indicative of a supply chain issue upstream. Maybe I need to adjust my safety stocks or my ordering lead time. Or perhaps there's an issue with replenishment. We're not able to get to that product because of its location in the warehouse. Again, this is just a zoom in on some of that data. So that's sort of looking backwards, thinking about what you can do with the data you have in your system and with the granularity that our execution suite can provide. But the really exciting stuff is when you have more granular data, it's not trying to get supervisors to look at a dashboard or your VPs or supply chain executives. It's actually giving them actionable insights automatically. That's what Mike's going to talk through.
Everybody hear me okay? If you can't, please raise your hand, because I know I can't hear myself with all the noise. So just on this slide, we talked about the left side of it. As Justin said, analytics is hard. If it wasn't, right, everybody would be doing it. But you hear about constantly from people, I want to know what my data is telling me. I need to visualize my data. It's not easy to do. To get up to the top, it's very hard, right? When you look at the bottom quadrant here, when we're just talking about descriptive and diagnostic, you often go through iterations with this cycle. Getting data from one system, two systems, pulling data out, learning from it, difficult. When you start integrating dozens of systems where the data is different, it doesn't have the same format, it doesn't have the same story to tell, it gets very difficult. So you often find yourself iterating through this bottom piece of this maturity model. Why do we want to move up to the top? Well, there's multiple reasons. All the dashboards we showed you are very important, but they're reactive, right? You talk to people and you say, analytics can tell you what's going on today, look at trends, what's going on in the future. An hour from now, if I give you that data, the state of your operations may have changed within an hour. If somebody has to go and manually look at that data, the decision you've decided to make at that point may not be worthwhile anymore. So by moving up this curve, we're trying to predict what's going to happen so that you can make those decisions very early on and not reactionary. One of the hard things about this is actually getting data. So you'll start hearing things like data lakes. Data lakes are simply a way for us to take all the data we know we have available and throwing it somewhere. We don't know what we want to do with it yet, but let's just put it somewhere, and then we'll figure out what we're going to do with it. Cleansing that data is when you start getting into things like data warehouses, data marts. We're now putting business knowledge on top of the data, structuring the data, maybe transforming the data to prepare it to move up this curve. It's not easy. So, how do we get to the point where we're being proactive? Predictive and prescriptive analytics. Through machine learning, artificial intelligence, data science, that's how we get there. Those are all buzzwords, and it's a magic 8-ball. We'll see here that it's a process. Machine learning is a process. The people aspect doesn't get taken out of it. We're still very important. We don't just hand over everything to a computer and say, figure it out for me. It's a process that we're involved in. So, what we want to do is we want to take machine learning algorithms, apply it to all that data that we've ingested into the system, and start being able to make these predictions. These models that we build aren't generic models, though. You do have to have a business case in mind. The models are targeted at problems, right? So if you don't understand what you're trying to predict, you don't understand the business problems you're trying to solve, you can't build a model. There's no one model that fits everything. And that's where data scientists and the people that are familiar with the business are hugely important. They define what's important. The computer only can learn from what we tell it. It doesn't go off and do it itself. So the years of knowledge that we've built up of our operations, that's what helps drive these models to allow us to do these predictions. The biggest benefit of this is that it's constantly adapting and learning from the data. As the business continues every day, day in and day out, all of that data is going back into the model and we're learning from it, right? What we learn today is going to be different than what's happening a week from now. But somebody's not going in there and figuring it out themselves. The model is trained to constantly take that data and adapt to what it learns, right? Seasonality will be learned through the model over time. Historically, we know engineered standards. That's what we've used to help measure performance, productivity. Very good, very reliable, but they're costly. And if you change your operations, you change the layout of a warehouse, you change your product mix, you move into e-commerce, what happens? Your engineered standards are out of date. And now you have to go and redo them, and that's more money. The idea with machine learning is it's going to learn those changes that are happening in the operations automatically, as long as your model's correct. And the model's going to be correct, we get correct information, we build it properly. Some of the things that we've started looking at is using machine learning and analytics and applying it to, again, we need business cases, dynamic slotting and workforce planning and management. Everybody understand what I mean by dynamic slotting in a warehouse, right? So where do we place products so that we can increase efficiencies of picking, put away, replenishment? Machine learning can help us solve that problem. It's a difficult problem to solve. So this is highlighting the fact that machine learning is a process. It's not that magic 8-ball. The machine learning piece is just that little algorithm square, right? That's how do we train this model? What's it trying to model? What's the business case or use case is trying to model? This is where all the neat nifty technology is going on. This is where our data scientists are doing their work and trying to figure out how to make sense of the data. But number one is you need the data. Most often you start with historical data. We have it, it's part of the systems that we have today. We have access to it, we can feed it into the algorithm, gets fed to the predictive model, we get a prediction out of it. We can then look at that prediction and see if it was accurate. Based off the results, that data gets fed back into the model. We're constantly learning from that. The interesting part here is the current data. So there's some diminishing returns. We can feed as much data as we want into these models. But there's a point at which the effort to get that data, make sense of it, and put it into the model starts to go down. So if you take a problem like slotting, dynamic slotting, historical data can show you over the last 6 months what are my high velocity products, what are the slow moving, and we can make decisions about where to slot those products based off of that. But think about it, last 6 months doesn't guarantee the next 6 months, right? Maybe I don't have any orders coming in for a product that was the top product the last 6 months. If I'm just using historical data, I may go and tell you to slot this product somewhere else, and now it's never going to get touched. Its position's been optimized, but I don't have any orders for it. By allowing the injection of current data now, you can make better decisions. So if now I take sales forecasts or some sort of planning information, that can be fed into the model, and my optimizations can be tweaked based off of future information. The important part is that, again, there's going to be diminishing returns to trying to get that data into the system. So any of these platforms that are built on machine learning, if it's not taking the data in automatically and learning from it, it has to provide the ability for you to inject knowledge. Yes, here's the optimization you've given me over the last year, but based off of my business that things are changing. Something like slotting, you may look at current events, you may look at weather, the workforce. That's all information that can change the decisions from a model. So again, we either learn from that data and we try to inject it into the system automatically, or we allow for that data to be brought in as part of what-if scenarios. That's a big part of this. We're going to present optimizations to folks based off of what we learned, but then we want to give you levers that can say, well, what if this changes over the next months? What if I want to prioritize replenishment over picking? What if I'm worried about safety and congestion in the warehouse? Play what-if scenarios, have the model regenerate optimization. Why? Because it's got the data. It knows how to model it, you weight it, and it can give you different results as a result of that. This just reiterates what I talked about a little bit. Historically, engineered standards, very good. We've relied on them for a long time. We think machine learning presents a different approach here that can give us, if not equal, but better results for a much lower cost. Engineered standards, very manual, static, very costly, and they're reactive. Every time we change something in our operations, we have to go and have new standards created. With machine learning, the model is doing that for us. As long as we keep feeding it data, the daily course of operations is going to keep sending data into that model, and it's going to keep getting smarter and learn and give us better optimizations based off of the current state. And again, not a month from now, that's going to tell us a month prior what to expect a month from now, so that we can be proactive. Why predictive analytics? If we can be proactive, right, we stop problems, or we find problems before they occur. We can adapt to differences across sites. We can see why one site's not performing against another one and try to make changes as a result. If you put it in the context, think about productivity. So another use case we talked about was workforce planning. So we're looking at the productivity of workers. We're looking at whether or not we can finish an order on time to put onto a truck. So we're trying to predict what we have to do in terms of workforce to get them in the right position so we can guarantee orders are going out. By being proactive and trying to figure out what's happening a month from now, you can take workers who maybe are not being productive. Maybe it's not their fault, right? Maybe products are slotted incorrectly. Maybe did I go out? Can you hear me? And if somebody up here doesn't have the visibility to that data, the workers are going to feel defeated, right? If you yell, there we go. It's back. Yeah, no, I can use this. That's fine. Testing? Okay. Oh, that's louder. So if we can predict where products need to be slotted, if we can predict the right level of workforce for the season coming up, we're setting up the workers to be more productive. We're setting them up to be happier, right? Happy worker, more productive, better for business, better for customers. It's all connected. But you can't do that retroactively, right? We have to be proactive with this. Machine learning allows us to do it. Lastly, the costs are reasonable because we're not going out and redoing the standards every time. We've built the model, the data's there. Once you build those pipelines to get the data into the system, it just works. Will you have to tweak it here and there? Sure, but that's built into the system to allow you to do that. I'll hand it back to Justin. Please come see us, 9619. We're very affable. We'll talk to you about anything we can do to help you, your workers.
So like I said, analytics is important for the managers to look back and understand what's happening in their DC operations, but the thing that we're really excited about is taking the granularity of data from a work execution solution like our own and putting machine learning models on top of that data and learning from it and providing recommendations that otherwise an analyst or a supervisor who is crunching the data and looking at it and spending hours on doing that real time with no training and no industrial engineers. It's very exciting stuff. So with that, I'll open it up to Q&A. If anyone has any questions, Mike and I are happy to discuss. Once, twice. Yes, that was, the question was the data we were showing, was that real data? Yes, it was. Yeah, so for the historical information, we had to build the pipelines to pull in the data. That project took only about a week of time. For the machine learning algorithms, we found that it takes about 4 weeks at a minimum of the data set to really build a strong model. We've been working with about 4 to 6 months worth of data, though.
And it depends on the problem you're trying to solve, right? So if you really want to understand how seasonality, promotions, things like that affect the model, right? You obviously need more than a year of data. You can see results fairly quickly, but as that time goes on, the accuracy is going to improve.
Any other questions? Yeah, go ahead.
Once you had that implemented, were you able to see sort of a return on, because you moved from idea or the interconnection between the businesses? Is there sort of an evaluation of where you made money from this or
Sure. So the question was, after we put in the prediction models, was it easy to see, did we actually make a valuable decision, and what was sort of the payback of that decision? So part of the machine learning algorithms is about making the predictions and testing the hypothesis. We're doing things in a more non-traditional manner, so we're not putting dollars associated to it, but it's more around time. Time is the ultimate denominator here, so that's what we're using for the information. From an ROI perspective, we haven't gone into the dollars and cents of it as of yet, but that's really what we're looking to do. We're trying to say, if we cut out 5 slot empties, 5 shorts, and we were able to reslot this product to reduce those replenishment needs, we can make someone more productive. They can pick 10 lines per hour. It's a question of, what does 10 lines per hour more mean to you?
And that's why we talked about the importance of being able to inject new data, because predictions can be, or optimizations can be presented, but only you're going to know what's the cost of following through on some of that. So that's where our cost benefit analysis will have to come in. Eventually, yes, you'd love to see that built into the model, but you at least have to present the data in such a way that those costs can be valued against the benefits, and you can make decisions on it. It may even be that you choose the next best optimization if you're presented with that, because maybe you know, from, let's say from a slotting perspective, the next best optimization may be great for you because you know you're already going and visiting a location to replenish that night. So I'm going to be there anyway, I might as well just go ahead and take some of these other optimizations. Not ideal, but they're going to be better than where we are today.
Other questions? All right, thank you for your time.